Hi everybody, it's Miss Austin. I'm going to be doing review packet number 1 to prepare for your final exam. Let me find the right one. Alright, here we go. So we are looking over functions. This packet covers our first 2 tests in the class. So first thing is we're looking at the domain. Domain is left to right. So I'm looking left to right. I see I have a discontinuity right here, so X can't be there. This looks like it's a problem, but then that takes care of that. That looks like a problem, but that takes care of that. And it looks like this partial piecewise has an asymptote right here at 7, but it equals 7 there. So everything except negative 7. So all reals, X cannot be negative 7. Name any and all X values at which F has a discontinuity. So that's a break in the graph. So I have a break right here at negative 7. I have a break right here at X equals negative 2. And I have a break right here at X equals 4. Find the value of each expression below. F of X equals this number in here. They're giving me the X value, and I'm supposed to get the output. So I just go to the X axis at negative 9, and I get 4. 1, 6. Negative 7, there's a hole there, so that's undefined. There is no output. Negative 2, open dot 4, doesn't exist there, but it does there, so 9. And then 7, 3. All right, another graph. Let F be a function of the graph shown at the right. Evaluate F of negative 5. Negative 5 right here is negative 3. State any and all X values or give estimates for any and all X values at which F of X equals 8. This time they're not giving me the X, they're giving me the Y. So I'm looking for all the X values when Y equals 8. So I've got that one, and that one. So it looks like at about negative 9.5, 3, and 5. All right, domain of this graph. So from all the way over here, and then it stops at 10, and I do have a break right there. So I'm going to go negative infinity to negative 3, and negative 3 to 10. And I'm going to put a square bracket here because it's touching. Determine the range. Range is up and down, low to high. So negative 4 all the way up to infinity. Name the X and Y intercepts. The Y intercept is where it touches the Y axis right there. 0, 5, the point. 0, 5. And then X intercepts, it's touching at negative 8 and negative 4. And negative 8, 0, and 4, 0. And that's page 2. Same graph, it says find any and all X values for which F of X is positive. So that's above my pen, right? Anything, this is positive, this is negative. So from negative infinity to negative 8, and then it goes below, and then it's back above from negative 4 to when it ends at 10. So and negative 4 to 10. And the next question says, find the set of all x values for which f of x is less than or equal to 0. That means when it's negative, below the x-axis. So just this chunk right here. So from -8 to -4. Determine the set of all x values of which f is got sidetracked. Determine the set of all x values at which f is increasing. So you read a graph from left to right. So it's decreasing, but it's increasing right here. So and this is on the x-axis. So from here, -6 to here, -3. So from -6 to -3, and it's also increasing right here, which is from 2 to 4. And it's also increasing right here from 8 to 10. Next question, where is it decreasing? Well, all right, so from -infinity up to -6. And this is constant, it's not increasing or decreasing. And then from 4 to 8. All right, state any and all x values at which f is discontinuous, and for each x value state the type. Well, there's only one here. There's a hole at x equals -3, and a hole is called removable. Find the value of this limit. So this is saying as I walk towards negative, as x gets larger and larger in the negative direction, as I'm headed towards -infinity, so that's this way, right? So here I am. As I walk towards -infinity on the x-axis, where's my graph headed? Up here, +infinity. And then the last question, describe the boundedness. This graph has a minimum, so it is bounded below. I like to think of it like trapped. It's not going to be able to go below that. So this is bounded below. All right, next page. For each problem, find a suitable domain for the function defined by the given formula. So when it comes to functions, things that cause problems with the domains are denominators and square roots. All right, because a denominator, we can never allow a denominator to be 0, and square roots always have to stay positive. So the numerators, there's no problem if there's no square root in it. So we don't even look at that. We just can never let a denominator be 0. So what would cause that to be 0 and -10? Everything else is okay. When I'm asked what the domain is, I need to give everything. So it's all real numbers, but x cannot be -10. You could also say -infinity up to -10 and -10 to +infinity. You could say it that way. All right, this causes a problem. You can't allow a square root to be a negative. So 7 plus x needs to be greater than or equal to 0. So x is greater than or equal to -7. That's my domain. Okay? This one has denominators, problems right here, right? Can't let that be 0, can't let that be 0, can't let that be 0, can't let that be 0. Not worried about the numerators. All reals, x cannot be 0, 6, and -3. That one's a repeat of that one. All right, D, double whammy. I've got a square root in the top and the bottom. So if the square root's on the top, it just has to be greater than or equal to 0 inside, because you can take the square root of 0. But on the bottom, I can't let it be 0, so that one's got to be just greater than 0. So I end up with two statements. I've got x can be greater than or equal to 9 if I solve that one, or x is greater than or equal to, oh, that was a positive, -2. Well, I need both of those to be true. I mean, think of a number line. This one says I need x to be greater than, oh, not equals, whoops, greater than -2. And then this one says, no, you have to pick up at 9. I want numbers from 9 and beyond. So these ones wouldn't work for this guy. So this guy right here is the domain. Okay, different possible answers here. So we're just supposed to sketch a graph that satisfies all these conditions. So here, what do I want? I want is continuous everywhere. Sorry guys, I'm looking for my, did I skip one? Oh no, here we go. Okay, sorry. Continuous everywhere has a local min at 5 and is bounded above. So there's no breaks, and if it's bounded above, it has a max, and it has a local min at 5. So, you know, it's going to be a little valley right here at 5. So no breaks, and I'm just going to use a pencil for this part so I don't mess up. So x equals 5. I'll just make that my low point. I'm just going to okay, let's double check. So I could have made this look a little bit nicer. So it's continuous everywhere, no breaks. Uh-oh, it just froze. Hang on, guys. We're back on. We're back on. All right, no breaks, has a local min at negative or at positive 5, and is bounded above, trapped above. Check. All right, next one. So it says, got 1, 2, 3, 4 conditions. So it says the limit of the function as x approaches infinity is 3. So when I'm over here, so to me that means I'm going to have an asymptote at 3. There's other ways to do it, but that's my interpretation. Ooh, so crooked. Has jump discontinuity at -4, has infinite, so this one, to me, that's an asymptote, right, at 2. And it has exactly one x-intercept. So, and it only has one x-intercept, so I'm thinking when I look at this, I'm thinking of our rational functions. So I'm going to make this one come in and approach 3. It has one x-intercept. So check. I've got infinite here. I've done this. I have to have jump discontinuity at -4. So I will do something like this. And then something like that. All right, many possible answers, but there's my jump discontinuity. Limit as I approach infinity is 3. 1 x-intercept, infinite discontinuity at x equals 3. All right, next one. Let f be the function defined by the dash curve below. I'm supposed to describe what has happened. Now, they're not giving me the actual rule. They're just calling this graph f of x. So a negative in front is a vertical reflection, which means across the x-axis. Plus 5 is a horizontal translation, 5 left, right? And then the plus 2 is a vertical translation, uh, 2 up, up, 2 up, okay? So personally, I like to do this in a couple of, I'm gonna do this one first. So this is just exactly reflected over that. That's 6, 3, 4, 4, 7, 8. So 7, negative 8. What is that? 4, 5, 6, 7, and 9, 1, 2, 3, 4. I'm just lightly fencing on this one. So, whoops, that one's off. No. 1, 2, 3, 4. Like that one. That's 5, 4. Sorry guys. 1, 2, 3. I'm blind. There we go. Some people do it all in one move. I'm not. So there's the first light sketch. And now I've done that, so now it's left 5, up 2. So I'm going to do each point. 1, 2, 3, 4, 5, up 2. 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 That's my final. Okay. Again, some people can go straight from here to here. I like to do it in a couple steps. Too much for my mind to handle. All right, next one, another function f of x. So the 1/2 is a vertical compression by a factor of 1/2. And the negative on the inside with the x is a horizontal reflection, which is across the y-axis. So I'm going to do this in 2 steps. The first, I'm going to do the reflection first. So 1, 4 becomes negative 1, 4. 3, 6, negative 3, 6. 5, 4, negative 5, 4. 7, 8, and 9, 4. 9, 1, 2, 3, 4. So this is what I have. And then this is a vertical compression. So this is compressing the distance, the outputs half as far. So right now that one is 4 away. So now that's only going to be 2 away. That one's 6 away. That's only going to be 1, 2, 3 away. 4 away is only 2 away. 8 away is only 1, 2, 3. 4 like that. And 4 is 4. Okay. 3. All right. Now we're going to reverse it. We're going to be given the rules, or not reverse it. We're going to be given the rules instead of the pictures and describe it. So this is a vertical compression of 0.25. The negative on the x is a horizontal reflection. This is across the y-axis. The 3 is a horizontal, and it has an opposite effect on the horizontal, so a number bigger than 1 is actually a compression. And so technically it's like a factor 3, which means a third. And then a horizontal, oh, sorry, vertical. Vertical translation up 18. Next one, all right, we have a f of x equals 2/3 to the x, that's an exponential decay. So the negative is a vertical reflection. It's across the x-axis. The 4 is a vertical stretch of factor 4. The -7 is 7 to the left, or sorry, right, so a horizontal translation 7 right, and then a vertical translation 9 down. All right. Now we're going to write the rules given the transformations. So our parent function is the square root of x. So it says we're going to reflect it horizontally over the y and shrink it horizontally by a factor of 1/8. So that's going to be okay, sorry, so that's the reverse effect. So we're going to go y equals, and inside here we're going to have a -8x. Because remember, this number does the opposite effect. And then, is that it? Reflect, shrink it, and then up by 5/4. I left a little bit of space there, but oh well. All right, now next one, parent function is a reciprocal function. So let's see, we're going to vertically, or stretch it vertically by a factor of 5. That's going to make that a 5. Reflect it vertically, that's going to put a negative out here. Translate it left 36, so that's going to be plus 36, and down 7.2. I do everything? Yep. Okay. Now this is a composition of functions. So we have a function f of x and g of x. So the first one says find the formula for g of x minus f of x. So literally we take g of x, which is 3 cos of x plus 8 minus, now because we're subtracting more than one thing, right, a quantity here, you need to put it in parentheses. You could distribute it out if you wanted, but you could just leave it like that too. Next one, f of x times g of x. So I'm just going to put these in parentheses. Okay, and then it says let h be defined by the function h of x is g of x divided by f of x. So h of x is g of x divided by f of x, and then it says calculate h of -8. So wherever I see an x, I'm going to put an 8, -8. That's 3 times the cosine. Whoopsie. Is good. 3 times the cosine of 0, all over, that would be negative 4, so that makes 6. The cosine of 0 is 1. 1 times 3, 6, or 1 half. So h of negative 8 is 1 half. All right, and then last one, finding inverses. Inverses, remember on the graphs, it's the reflection over the line y equals x. So the x and the y's are reversed. So that's our first step when we're solving. We switch x and y. Right now that says y equals, so it's now going to say x equals. And that's going to say, and now I'm going to rearrange this to get y alone. So my first move is going to be to divide by the negative 3. And then I need to get rid of the square root, so I'm going to square both sides. I have x over negative 3 squared equals y minus 6. And then my last move is to add the 6. I'm going to write my final answer. The inverse function is x over negative 3 squared plus 6. Alright, next one. Same thing. I have a new function g of x, so I'm going to switch x and y. And I'm going to get y alone. So my first move would be to subtract 8. I see something in the denominator, so I'm going to multiply both sides by y plus 1. So that cancels. So now I have y plus 1 times x minus 8 equals 4. Trying to get y alone, now I'm going to divide by the x minus 8. Y plus 1 equals 4 over x minus 8. And I'm trying to get y alone, so the last move is to subtract 1. I'm going to write my final answer. The inverse function of g, is 4 over x minus 8 minus 1. All right, guys, that's a wrap for the first packet. I'll see you soon for the next one.